Okay, so I'll have to just start with a little warning that I'll have to leave at 12 o'clock. So I'm happy to present and really open for discussions, of course. But I'll try to do, if we have many discussions, I'll try to highlight the main ideas here. But as Frederick presented, this is like a code generator that we're working on. But as of recently, we made it part of the LIO project. So it's actually downloadable in the LIO project. And we've been more open, of course, than in this way to for further cooperation, both in terms of using it, but as well as sort of working together with the code generator. So yeah, I'll quickly just, my idea is that I will focus on a demonstration of this, just to show you what it can do and what it can't do, and just start with, like, you know, how we see about generation and sort of what is the technologies we're using, just to show you that it's quite thin actually. Okay, so why are we code generating? When you do this, there's a lot of repetitive steps when you're trying to develop a new adapter. Basically, if you look at from your instructions, Stefan, so we try to automate a lot of those mechanical steps so you can focus on sort of the unique development needs for your particular tool. We also, I mean, there's lots of technologies. So one reason to generate is you can make a lot of this OSLC technology transparent for the tool developer, so they can focus on like the internal development of the tool itself. And something from the MBAT project, we talked a lot about patterns and stuff, and we believe that patterns could also be either guidelines, but you can also sort of implement them in the generator. So you can sort of choose what pattern you want to solve, and then the code generator will support you with that. So basically, we just want to reduce the learning curve for adopting OSLC. If you want to think of it as an OSLC strategy, let's say. And we do this by modeling the tool adapter, and then from that model you can code generate. But not only you can code generate, I mean, from a model you should be able to do analysis of your tool. You can do all sorts of different things, given that it's an executable model and not just a picture, as the current specs of OSLC are, for example. Okay, quickly, we base this generator on basically EMF to model, and sorry, I have a cough also. How do you say this? Axelio, Frederick? Is that the right name?
Yeah, in French we would say that.
Thank you. It's a French thing. So basically you have the EMF model, and then from that you have a code generator which takes models and makes Java code out of it. And then here you can see the basic list of Eclipse packages, just to highlight that it's quite little actually outside of what is needed from OSLC. It's basically the EMF and the Axelio, which is new. And just practically, you just need to have access to two projects which are already part of the LIO project, the adapter model, and that's where we're collecting the EMF models of both adapters, but also of the OSLC domain specifications and everything. I can show you what they are. And then you have a code generator project. So what I want to do now is go through like a complete step of stopping from creating a project to start developing a tool provider down to code generation and execution. And I'll do this by demonstrating how you do it for, let's say, a very basic MATLAB Simulink setup where you just want to access the blocks of a Simulink model. But then I'll show you also the Bugzilla adapter, which is what the LIO workshop, if you've done that from OSLC, they explain how you build a Bugzilla adapter. And basically the approach I've taken is that we've sort of taken that workshop and basically code generated out of it. So we produce exactly the same code that you get out of the workshop. Okay, so the steps that I will go through is I will create a new project based on your instructions, Stefan, basically. And then you create a model of the adapter where you define that adapter. And this is the point where I'll explain to you how we, sort of the meta model of an adapter. And then you configure it, you configure your code generator, and then you sort of run from there. What we generate is only the skeleton of the code. So then I will highlight what is it that is generated and what is it that you need to implement yourself still before you can actually run the adapter. Please interrupt me. I will talk quickly so I can have more time for discussions or questions. Okay, so I'll switch to Eclipse now and show you what I don't know if you could see both screens, but I'll basically go through these steps one thing at a time. So basically you need to create a project, and here I assume you do this manually. This is something we can automate, but I assume it's you have an empty project to start with. We have some instructions where we've reduced your instructions, Stefan, to, let's say, 5-minute work. So to actually create this, where you download lots of ready-made configuration files. So what you have here is basically what I will work through here is this demo adapter, which is it's a setup of a project, but there's hardly any source code in it. It's only the setup of the web services and etc. in the XML files. And then the next step, once you have this step, which is, I'm cheating now, I just said it's like a 5-minute job, is to actually create and define your adapter model. And what you do is you simply just have a place where you put this model. I'll just create a folder here to keep things neat under my project. And then you see here, this is the OSLC4J adapter model. And I will explain this actual meta model in 5 minutes. But what you need to do is simply create an instance of this adapter interface. And then you specify that you want to have it under your project, just to keep it neat. And then what you will have here is this, the instance of the meta model that you can start populating. Okay, so that's like just a mechanical step also. And then you need to go into this and start sort of defining the meta model. But before I do that step, I can sort of explain to you what this meta model is. So basically what we've done is we've taken the definition of, you're not meant to be able to see this so much, but this is how OSLC sees its resources. You have service provider catalogs that list service providers that have services that contain queries and capabilities, etc. So we've created an EMF model out of that. Sorry, again. And that's an EMF model I'm representing as a class diagram. But this is actually what's in this E-core model here. I thought this was more graphically easier to see. Basically, you have two branches of this. The left side, where you have the service provider catalog containing service providers, containing services, and then containing these capabilities. And that's really exactly what the OSLC core defines. All these properties you see within each of these classes, title, description, URIs, that's exactly what's in the OSLC core. And then on the right side is actually, so this is actually what you want to implement on the left side. On the right side is actually the set of domain specifications that your adapter wants to implement. And this model is also the way OSLC sees domain specifications. A domain specification, is this big enough text or should I make it a little bit bigger?
I think it's fine.
Yeah. So a domain specification consists of a set of resources and a set of resource properties. And then from a resource, you list the set of resource properties that you want to contain, which means that these resource properties can come from different domain specifications, both your own or the core or RDF, RDFS, etc.
So here you basically specify the OSLC vocabulary
exactly.
You would like your adapter to be exposed.
Yeah. So I will show you how it will look like in reality also, but this is just the meta model of it. So this is when you define resources, and then your capabilities here and factories will refer to these resources, which can come again from different domain specifications. So this is actually a way you can model this differently, but this is what we found made it executable, both in terms of you can analyze it, but you also sort of from that you can co-generate any specification. We've tested with it at least. So I hope this is clear as quickly as I've done it. That's pretty much what it is. So now we'll go and just to show you how you do this, you open this adapter model, and then you have the interface, you create your catalog, and then you fill in its properties here, the description, and the title, etc. And then if you're familiar with EMF and how it works, I think this is like just standard way of, you create a provider, and then from a service provider catalog you have service provider, and in the meta model you can define more than one service provider per service provider catalog. But the model we have for the moment, you have only one service provider catalog per adapter interface. There's just a simplification we've made. And then given the service provider, you fill in its properties, and then you go ahead and fill in services, etc. And I think if you don't need me to, I think I will leave that at this level. Was there a question?
Yeah, I wanted to ask a question.
Yes.
If you would think now of a more complex tool, where you say, let's have you have several projects in this tool, then each project in this tool would normally result in a service provider you're defining here now.
Yes.
So I don't know how this could be supported then. So also the service providers would be kind of automatically generated out of the basic data you want to provide.
Yeah. I think just to clarify, so what I define here is not. I think that's similar to, for example, in the Bugzilla case, where every product becomes a service provider. What we define here is a service provider type. So basically what you do in your code, which you have to implement yourself, is that you have to do the mapping of instantiating this service provider type per project, like you said.
Okay.
Yeah, so there's a bit of confusion in the terms here. So this is actually what you're defining exactly. So when I define many service providers here, it's because I want maybe, you know, a set of service providers to manage projects, maybe another set of providers to manage, I don't know, files or some other kind of resources you want to handle with different kinds of service providers. Okay? That's I think we need to work on the terminology with this model also. But that's yeah.
I was always confused also if you just think of the blocks you have to implement. That one block you have to implement, you call it the service provider, and on the other hand you have all these XML documents that describe the OSLC interface. So the self-describing documents, and also there you have a document that's called service provider, but it's not necessarily the same as the block you implement. So I think this is also the confusion we're talking about now.
It could be, yeah. Yeah. Okay, so anyway, so back here, so this is what I've described here is quickly the left side, which is how you define your implementation, let's say, and then you can go back and define your. This is just a container, and then you put you create your new domain specifications that you wanna build on, core or whichever you want. But what you can also do is you can load existing specifications. So we already have defined part of this project in the adapter model. You can see both the e-core meta model, but also for now I only have the core and the change management domain specifications. So if you include this one here in your project, then when you're defining, let's say, when you create, let's say, a resource, part of what you do when you define a resource is it's, you know, sort of its name, resource name, and then you set up which properties you have. And because you've loaded all these things, you will get all the properties from the change management specification already loaded, which in turn loads the core specifications. So you get all these for free. So it's just about adding them up, and you have it here. I'm showing you a very speculative example here. So once you've done that, you pretty much have your model here. I can show you, for example, how the Bugzilla meta model looks like, just to clarify, or to give you a more, I don't know, impressive model or something. So here you say they only have the Bugzilla domain specification, but in reality, if you look at one of its resources, it's using many properties, but they're coming from the, or not these ones. Let me see how you do that. Okay, that's right. So it's extending the change management resource, and that's a shortcut to specifications which are outside of this meta model. So it's linking to the ones we already have. So that sort of reduces also the amount of work you want to do. You can download someone else's domain specification and then sort of use that and extend it. Okay, so again, I don't have time to show you exactly how it is if I want to code generate. So what I'll do is I have another model where I've defined a resource called block, and it's got properties called name and type, and then also sub-blocks, and this is what we will code generate from. So I'll take a copy of that model, which is here somewhere, and I'll put it, where is my, here. Okay, so let's just clean up a little bit here so I don't make a mistake. So this is my model I'm gonna assume I've worked hard to do with you now. And then what I have to do now is just set up my, so I have my model, I just need to set up my configuration to code generate based on that. So what we have here is this project called code generator that takes such an instance of the e-core meta model and then generates code from it. Where was I? Run configurations. So okay, again I've cheated a little bit yesterday. So you basically create a new configuration where you tell them where is your code generator, what model can you see my highlights?
Yeah.
Which model you want to generate from, and this is the demo adapter model, Simulink adapter, and then the target is also which project are you going to generate from. Okay, and I hope this works. You never know. Let's see here. So as you see here, there's hardly any functions, any classes here, but once I generate the demo, this will take this meta model and then generate problems. Right. This isn't going to find the path specified. Okay, let me see if I can quickly fix that. Did it change anything?
Yeah.
Okay, it looks better. Okay, and that created 23 files for me. So basically what I have here is all this stuff is newly created. I can quickly highlight which classes have been generated. The obvious one is, the actual resource. So what I said is we have a resource called block. So I will generate this Java equivalent project, class called block.
So this is the OSLC vocabulary mapped onto OSLC4J Java classes. Huh?
Yeah. So based on this model, it will give you the resource. It will give you sort of get properties. Let's say get child, get block type, get title per property you've done. You will have some helper functions, how you transform this to HTML, which all the JSP files we also code generate can use. And this is a typical example where there's a standard way to represent a resource in HTML by saying get about, but there is space for you to sort of customize that. So whatever you put, if you want to go in and change the way you want to represent it, you can put your Java code in between these lines here, and that will override, of course, will modify the generated. And next time you modify your model and code generate again, anything you write between these lines is maintained. So you can always iteratively develop your code. There's also helper methods to, if you want to represent how you represent a property in HTML, both to represent it, but as well as to when you want to create it or modify it, etc. And again, you can override these. But the good thing is, if I know a property is a date time, I can already provide you functionality that represented as a date time, how to create it. So that's also saves you a lot of time. We don't have that yet. I represent everything as string, but this is actually, the mechanisms are there to do that. Things like validating your properties, you already know it's a date time, then you can also check that the user entered at date time. And that you can also automatically generate that kind of validation. We just need someone to implement this functionality. But it's just about putting them in your code generator. Okay, so so what I generate is these resources. Per resource, I generate all the constants in a human readable way. This is all generated, so I know which domain specifications you're using, which resources you're using, and then you get all these static constants that you can use. All the services per resource as well as the catalog you get, and this is where you do the get and post and delete and all the dialogues, etc. That's all code generated. And finally also the JSP per resource, how you represent the block, how you represent the block collection, how you create a block, depending on what you've asked for, how you search for a block, etc. That's all in there. There's a lot more you can do, but this is what I've limited to that for now.
Sorry, I have a question.
Yes?
For the, I think it was services or also the model. Do you create a package info Java somewhere also with all the namespaces?
Package info, it should be there somewhere. Yes, I never. Here it is.
There it is.
Yeah.
Because otherwise you would miss some of the namespaces and so on. So
yeah. So this way, and this again, what I've done is I've taken the Bugzilla code and I just copy pasted and then generalized it, and then validated again by using another, like the Simulink tool. So I'm using the pattern of what they have there, with certain modifications, of course. Yeah. Things that I don't have, for example, now is this authentication thing, but that's also again just about time to putting it in there. But I've limited to which ones I've done.
There's also a whole project for OAuth authentication and some like store you could use to save your users and so on. So I know that in OSLC4J there's also some thing you could copy and maybe generalize.
Exact. Yeah.
To support OAuth.
Yeah. Yeah. So I mean, I can see this sometimes as, you know, you can. We have partners here. They're doing their adapters by copying and pasting from the Bugzilla workshop. So this is a sort of a slightly better way of doing that, because the code generator has done that copy, and whatever changes you want to do across all your projects, you just put it in your code generator, and that will propagate through all your adapters basically, instead of having to remember what you copied and what changed, etc. So it's a very, in a sense, a practical way of having a workshop code. So basically, what everything is there. The only thing you need to fill in, as I showed you, you can go in where I thought was relevant to show some to allow the developer to add stuff. You can modify your code, but all these other classes are ready to go. The only thing you need to fill in is this class called Adapter Manager, and there you need to provide, for example, here some functionality to sort of, if you need to somehow connect to your tool in a way. This is where you establish a connection. This is where you destroy your connection, especially for Bugzilla. You know, you need to sort of log in to the server. Here's an answer to your earlier question. There's a function where you need to give me per service provider type you've defined. You know, give me the set of, return the set of service providers for that particular tool. And this is an internal bit of code you have to do. And then per resource, you also have to say, you know, give me a block, given that you have its ID. Give me a set of blocks, given a set of, you know, the page and the limit, or it could be terms, as in if you want to do a search. And then the functionality to actually create a block, and that means create it in the tool itself. If you have a creation dialog, for example, creation factory.
Here you have to do kind of the mapping of your tool internal data to
exactly.
Specific types of your OSLC interface.
Yes.
Okay.
Exactly. And this again, you can do a lot more. At the moment, I'm leaving it very. It's pretty empty, but I think, and this is where, so let's say, patterns come into it. You can do a lot still in terms of caching stuff. You can provide, you can generate a lot of help functions, let's say, to make that job even easier. But the structure is what we're aiming for now, and you can do it better.
Storage of resources will always remain in the tool where it comes from.
Yeah.
Like it is for Bugzilla.
Yeah, exactly. This is sort of, for me, this is how OSLC works. You can do that. You can do a lot. So let's say caching, for example. So what we've been discussing is you can provide that kind of solution where you do, so you don't have to ask all the time for the information. You can cache it and then somehow provide functionality to clean the cache or update it, etc. But that's not really OSLC, let's say. That's really how you choose to implement it and optimize it.
I wouldn't say you always do it like that it's just like a facade on your existing database or something like that.
Yeah.
It might depend completely on the implementation, what you want to do, but yeah.
Exactly, yeah.
Yeah, so it's really like what we're discussing about. It's like really tool-specific features. But nonetheless, when you consider all the different possibilities, you can see some patterns. So you can see that, for instance, the tool used behind the scene does not have an internal repository. So, for instance, you could generate automatically via the code generators the access to a distributed, decentralized repository wherever it is like deployed.
Yeah.
So you might how to say want to tailor the generation process of your adapters depending on those tool-specific patterns that you have behind the scenes. So it's like it's something we can think about as potential extensions for sure.
Yeah. Yeah. Good. Right. So how good? Let me see here on my. Right. So I've actually. Yeah. So I've generated and then. Okay, so let me see if I missed something here. What is it you generate? So you generate all the Java classes, all the delegated UIs, the JSP pages for HTML and JSON. Everything is generated. I quickly showed you the content. What you need to develop is this adapter manager, which is to access the service providers and the resources, and etc. Yeah, that's it.
For the HTML, you're just generating like. When you click on the resource itself, or you also generated some dialogue stuff?
I can quickly, just to see if I answer the question. So this is how you represent a block, let's say. So, and this is completely generated. So somehow you have a summary of the resource, and then you iterate through. So it's quite a generic way of representing a block. And you can see that I'm actually calling resource functions to represent the properties in HTML. And this is like how you represent the set of children in HTML. And here, there's a standard way of doing it, like the code generator way, but you can always customize it. And if you customize it here, then in all the HTML pages that call this function, you will get this for free. So this is, you know, where things end up. So your question was, I mean, I generate a...
My question was, if you go to the service provider and if you go to a service, just if you browse through the XML of the OSLC interface, there's also mentioned something like a preview dialog or a selection dialog and stuff like that.
The query
so
capabilities.
HTML kind of address, or it's just the JC address, and then you could define maybe ID of a resource, and then you get this dialog.
Yeah.
I don't know if it took care of these dialogues or not.
Yeah, but I think this, if I understand you correctly, for example, this is the block creator, what I call it. So this is actually the, when you call the block service / creator, this will actually, and then you actually, which service provider you have, and that will redirect to block creator HTML JSP. So that will actually give you the HTML page to create a block. Is that your question?
I think so. I was just coming from, if you go through the OSLC spec, and if you just, let's say, climb through the documents your OSLC interface provides,
right.
You come to like service provider catalog, then you come to service provider, then it shows you the services it offers, and
right.
At some point you will get an address where you can just go to a selection dialog or to a preview dialog for each resource.
So, yeah.
So I don't know if you kind of made it into that and you come just to these JSP pages, or you're not supporting dialogues at all. That's my question. But I think you do what I see now.
I think
it should be on the services. It should be at the beginning of the creation factory and the query capability. You should have the exactly. You don't have it.
But not this one. OSLC dialogues.
Yeah, exactly.
Oh, okay, yes, I do. Well, sorry, but okay. So in this particular case, I haven't defined any. But if I show you the, okay, let me see if I show you for the Bugzilla one. Yeah, so I do support it, but I have to say I haven't really. Let's see if they have dialogues here. Am I in the right one? This is wrong.
There's at least the preview dialog and the selection dialog, what I know.
Here. Yeah. So this is what this is what you're after, right?
Yeah, exactly.
Yeah.
Because what you would show in this dialogues will be most likely not very much different from what you make now, what you showed me now with this JSP file.
Yeah.
The content would be more or less the same.
It is the same. That's true, but that's actually, it's a bit trickier. So yeah, I do support it in that way, but I haven't really properly tested it because I needed a client that needs this delegated UI. We're talking about delegated UIs now, and not just a clean HTML on a web browser. And that sort of needed more testing. But I do support it. I do produce the same code that the adapter, so that the workshop does. So I trust that it works. But I need to do more thorough usage of it to really test it properly. But that's the whole workshop. Just to say, you know, we're still in the development phase, so there's a lot of testing to do, and you know, the more people use it, of course, in different tools, that's where the things will come up. Different needs, different problems also. Yeah?
Who is working on it? Is it just you, or you have already found someone else in the OSLC4J community who might want to help and so on?
Well, we just actually became public in like last week, less than a week ago actually. So let's see how many people are interested. But we have at least one, and now another project starting. We will have partners that are both using it, but by using it, they're going to contribute to fixes and new features. But it's just now we're starting to talk about it, basically.
I can imagine, especially for my task within a Crystal project, I could really make use of it because, as I already spoke before with Laura Frederick, we will also map some ODS schemas, and I can imagine it would be much easier to do that by integrating the properties and the complex types, the model of them, in this way into OSLC adapter implementation. So far I understood it should be easy, and this way it's easier also to maintain, to know which parts of the schema has been mapped into OSLC resource providing the content.
Okay.
Provider.
So yeah, I think that it could be of high relevance from your side in Crystal, and we would like also to promote a bit more those tools in the project as well. So in Crystal, I already proposed to make some presentations and demos about those tools, and then if some interested partners are willing to rely on the code generator, they are welcome to do so, since it's publicly available from the Lio platform. So it's like so we do really believe that it would be really helpful for you, for instance, Solver, like kickstarting the implementation of OSLC based adapters. But of course, it might be also reused in a broader scale within those projects. So now it's just a question of promoting those tools and providing basic supports for helping out people kickstarting using it. And Jad, you have been already working on a quite let's say extensive documentation. So it's quite easy for someone for a newcomer to try to rely on the code generators actually. Yeah.
For me, I'm definitely interested, and I would appreciate some links or maybe some access where I could download the code and try it out in like part of my preparing for this implementation I mentioned at the beginning. Maybe the Jad was not there, but maybe to repeat it once again, I gonna contribute to the work package 3.4a at Crystal, where we want to integrate the data backbone consisting out of the ASM ODS schema-based web services, which provide us some data, and we want to provide an OSLC adapter with a focus view on a set of properties interesting for the upper levels of applications for AVL using OSLC, as I said. And I think exactly this step of preparing the infrastructure for a service provider in general and the services, and then mapping the ASM ODS schema that we're going to use, which is still not fixed. This step could be automated in this way. As I said, maintenance of this mapping, you can keep track of this mapping much easier, because Jed already mentioned if you have to copy all the files and adapt it manually, it's way too much work, and you don't have the overview. With eCore module, it's much easier.
Exactly.
Definitely a pro for this approach.
So for sure, we will be providing how to say an entry point for the documentation and the code, and so we can do that for sure.
The aim is to, I mean, it is one of the reasons we have it on Lio is to make it open. So it should be, the only thing I haven't managed to put there is the documentation. So I aim to put this documentation on the wiki, but until then you can have access to our local, a Word document, let's say. But then it's a matter of also if you wanna work closer, we have a Git repository at KTH, so you can have access, both contribute directly to, either we work together on fixes and features and then contribute to Lio, or you can contribute directly to Lio, or, there's many possibilities on how close we want to work. And we're open to both.
First step that I personally want to make, I want to try it out by myself. This seems really useful. You demonstrated quite well, but before you don't get the feeling.
What
really works, you cannot say anything about it, but I'm quite convinced that it works. It's not just a demo.
No.
However, as demands evolve, also out of my perspective, I would be definitely interested to contribute. Why not?
And I have just a question, an idea I came up with, that this vocabularies, if you come more from the semantic world, normally are defined in ontologies. And did you ever have the thought of you can load now XMI models or eCore models or something like that, that it might be interesting to get in ontologies somewhere into all that and generate an OSLC adapter out of that for your vocabularies? Because I could imagine that maybe some people who work with the semantic web already say, okay, I have some vocabulary here, but it's stored in an ontology. and it would be beneficial to use that already existing vocabulary.
Okay.
That's a good point. Yeah.
So I think this might be something quite interesting in that context.
So it's like something that you.
I have no clue how technically you could do it or how you could really bring it into that.
So you could do it manually already, because when you define your own vocabulary manually using this EMF meta models Judd showed. So you can already do that manually. Then the question would be to what extent we could automate the generation process of the OSLC vocabulary from the ontologies. Yeah.
But I mean, I'm not exactly familiar with ontologies and the technology, but I mean, this is one way we're envisioning this, that what I have in this eco meta model is like very loyal to the OSLC specifications and the way they're thinking. But on top of that, you can have layers of different sort of interfaces, so you can use other things and you do some sort of transformation to this to the OSLC layer, let's say. So we can support that or otherwise, or so there's definitely a room for that. But that sounds interesting.
Yeah, just to clarify, I mean, okay, you said that you're like somehow bound to OSLC specifications, but it's only the case for the OSLC core resources actually. Sure. On the left part of your meta model you showed on the graphical representation, the right part, I mean. You might want to implement your own vocabulary.
But that's sure.
So it's
but the model of I mean, this is how OSLC models domain specifications or C domain specifications exactly. Yeah. But that's just because. But the same as the code. I mean, when you code, once you code generate, my vision has always been that you don't have to generate. I mean, it supports iterative, but what you get is purely OSLC4J code that you can take it, run with it, and do what you want with it. You're not bound to use the code generator as much as possible, and that's sort of the way I'm thinking. I'm supporting OSLC4J just for practical reasons. Then you can build on top of that without having to bound people to ontologies or whatever. This should be built on top. Okay. So
and just very last thing is like so far you are generating code for OSLC4J, so it's like for Java Java technologies, Java platforms, and so it's somehow a limitation because only Java so far is supported. So, but we could think, of course, later on about supporting .NET or like other programming languages as well.
But that's the thing, we get a lot for free because OSLC4J provides a lot.
Yeah.
So I don't know, are you interested in showing it? Do you want to see it running? Because I can try to do some. It will take me like 5 minutes to actually. We have only 12 minutes, so I'll just go through what I had to. Yeah, I was thinking that I can show you what you need to fill in and run the adapter. But okay, the way I've done this is I've basically duplicated the Layo workshop. So instead of doing a copy of that, you can use the code generator. And then I tried to stick to the OSLC model of the world.
But you have already like the Simulink adapter. Maybe you can show just some piece of code and execute it. And
so if you trust that what I have here is the. So basically, what I've just to show you what I've done is I strictly filled in the adapter manager where you provide functionality to, like you asked, what is a service provider? And in this model, I've said every MDL file becomes corresponds to a service provider. And then I have functionality to connect to MATLAB Simulink and then get block.
So here you are, So here you are describing the code that you manually implemented to bridge the gap between the generated adapter and the Simulink interface. And in your case here you have the concept of block that is exposed, isn't it? So you have like Simulink blocks that are like interrelated to each other.
Exactly. So blocks contains sub-blocks and they have only these basic properties of name and So it's a very basic implementation, of course, just to demonstrate.
And so now you are executing the adapter that has been like generated and
So now you're just running the project and then you will be able to, once it's alive, you can communicate with it. I'm running on a very slow computer, so if you demonstrate it next week, I could have shown you that it will go much quicker. But so I don't know if that's worth it. But I mean, I can show you around but otherwise, I think my demonstration otherwise is sort of. I hope you got an idea of what you can do and what you can't, and sort of how it works. Okay, so this is your interaction, and I have what I basically have is for this bit. for this particular case, you have I just happen to have 3 models, very basic models. So for each file, for each of these files, I have a service provider. You go into the service provider, and then you can look at its blocks. And this is in turn going to be talking to MATLAB. So this should not be visible really. It should be on a server, of course. I'm running both client and server. So I hope you're familiar with Simulink and how it works. It's pretty much a graphical interface. So what you don't see now is my hard disk crunching away because I don't have so much memory, and that's why it's slow. So this is my very basic model of, just blocks, and then you open a block and there's blocks inside of it. And here you see the list of, this is very basic representation, and then you can go into one block and then you can see its children, in this case only one, and then how you represent it. And this is what you can go and change in the code to say how you want to represent it. Maybe you just want to show the name as a representation with a link in brackets or whatever. Then you change the code and then you have it.
Hello?
Yes?
Yes, okay, so we are back. I don't know, our telephone dropped, so we didn't hear the last 4 or 5 minutes.
Oops.
But it works. We saw it.
Yeah. So did everyone not hear me, or?
I don't know, it was just for this. Our telephone just hang up, I don't know why.
Okay. Yeah. So yeah, I was just demonstrating basically, I could quickly show you. This is the list of service providers, one service provider per file that you can see here. And then you can click on this, you can see it's, this is basically HTML, so it's basically for debugging. And otherwise you can also, I'm not sure if you can look at its resource shapes, etc. And then you can create, but this will not work, so I'm not click on it.
And you provide, of course, XML RDF representation also of all the resources, because here you are just showing the.
Yeah, sorry. So what? Yeah, exactly.
XML.
So this is HTML, but then when you choose this one, if you have the right, I don't have it installed. Then you can choose whether it's RDF or HTML.
Go to your address line and just put their question mark equals. And you would get it. You can try it.
Okay. Here.
Put a question mark.
Yeah.
Then ALT.
ALC.
No, T like Thomas.
So.
Equals. And then you write application.
Slash. Okay.
Yeah. And then you write RDF plus XML. I think it should work.
Let's see. There you go. Okay, so I normally use this
JSON,
client.
Then you get JSON.
Yeah. Right.
So this is just what OSLC4J does for you.
Exact. You get all this for free. Yeah. So this is actually the second implementation we have. So previously we had another code generator that had to do all this itself, and now we rebuild it based on OSLC. So we save a lot of effort on that. Yeah. So this is what I had to quickly, unfortunately, I had to rush through it also. But
thank you very much, Jad. I think we got the idea. Yeah.
Yeah.
For sure. Any other comments, questions from your side? Maybe from Germany.
No.
And from your side, Solver and Stefan.
Yeah. What would be really interesting is the point that Stefan mentioned.
Yeah.
To find a way to make a mapping or automatic mapping from ontology or properties of ontologies to a XMI model that could be loaded and then integrated into a generation of the providers.
Yeah.
I'm very happy to work with this. I'm very interested in ontologies. It's something will want to start looking at it, but that's not my expertise. But I'm happy to open up such a discussion and see how we can do this. It will be very relevant for me, so I can. Yeah.
Coming from the W3C approach, now I'm diving into the OMG world, I would say, and maybe I get involved in some way, and I definitely want to try it out and see.
Yeah.
I can help you on these issues with ontologies.
Yeah.
Yeah. Yeah. Great.
Excellent.
Thanks. Excellent.
Let's set something up. So I mean, you showed interest in documentation also. I think Frederic can just help me out. I can distribute what we have.
Yeah, sure.
Either if you want access to our like the Git repository we have, so you can get the latest patches also before they're released to Layo, or for documentation, or whichever way you want to do it.
That would be great. We could get.
Yeah. Okay. I'll come back to you shortly with more information. Yeah. As soon as it will be packaged. Yeah. Okay. Excellent. So thank you very much, guys, for attending this presentation. Thank you very much, Jad, of course. And let's keep you posted in the further developments of those tools. So looking forward to discussing with you guys about those exciting topics. Great. Thank you very much. Bye bye.
Thanks, guys.